welcome back to Glaciers and Glacial Geomorphology, and we're carrying on now with our session on glacial erosion. We're talking about processes, landforms and landscapes of erosion, and in this video I'm talking specifically about the landforms and the landscapes. I'm not going to give you a comprehensive encyclopedic review of every single glacial landform and landscape and how it's created. There are plenty of those for you in the literature, either online or in the basic textbook. There's a section, or in Ben and Evans' Glaciers and Glaciation, which is itself a detailed, comprehensive source on most things to do with glaciers and glacial processes and landforms. Chapter 8 in Ben and Evans will give you the factual information that you need to get some examples of the things that we're talking about today. What I'm going to do is give you more of a way of organising that knowledge and thinking about that knowledge and kind of classifying the different types of landforms, landscapes that you'll encounter, having previously given you some information on the processes that lead to the formation of those landforms, and also of course stressed the importance of the glacial conditions that control the processes that create the landforms. So that's where we are in the module, and that's what I'm going to talk about for a few minutes in this video. So thinking about landforms of erosion, we can think of landforms at a variety of different scales. We can think of the micro scale, where even on something as small as an individual rock, I'm not sure if you can see on the image here, striations on this bit of rock where a glacier has ridden over it and changed the morphology of the rock. So there's micro scale striations, polished grooves, fractures. Mesoscale, middle scale, tens of meters maybe in scale, whaleback, thrush moutonnées, those kinds of features. And the macro scale, where we're thinking about pyramid peaks and U-shaped glacial valleys and all these kind of GCSE landforms that you might have encountered. And broadly, as it says on the slide there, most landforms of erosion are either some kind of depression, like the grooves or the corries, or some kind of protrusion which is left behind after material has been eroded around them. But always think on those different kinds of scales. And this is a table. You might need to go and you might need to pause the video and have a closer look at this, or look it up in the literature and look at it in more detail. But this table from Sugden and John, 1976. Divides landforms up in terms of their scale. So first of all, it talks down the left-hand column there in terms of the different processes that are going on, whether you're talking about ice affecting a whole area, or if you're talking about linear flow within a specific channel, for example. Then, as I just said, it divides the relief types up into protrusions or eminences and depressions or holes in the ground, whether they're streamlined or not, and then looks at a variety of different scales. From the micro scale at the left-hand end there, you can see striae, striations, these tiny little features at the left-hand end of the scale there, down at the level of centimetres or less, and then working up, moving towards the right of the diagram, to larger and larger features. And at the right-hand side there, you'll see we're moving out of the category of individual landforms and into the category of landscapes, and they talk about landscapes of aerial scouring and landscapes of ice sheet linear erosion and so on. So we can think in terms of different kinds of processes going on, creating different relief forms over a variety of different scales. So as you're reading up on individual process form relationships, try to put the things that you're reading about into that kind of context. And here's an example of micro landforms, and that is, in fact, that's Dave Sugden himself of Sugden and John and other fame. And there he is pointing out some striations on bedrock in Greenland, and you can see also some crescentic gouges and other erosional features in that shot. And then in the bottom left-hand image there, those are just some striations, again with someone's toes for scale, some striations on a rock in front of the Athabasca Glacier. So those just illustrate the micro scale of glacial features, erosional features. Here we are at the mesoscale, and we're looking, well, in the foreground you can see some polished bedrock and also what we call moutonnées bedrock, where there's a streamlined upstream side and a plucked or fractured or steeper facing, a bit like an escarpment in geomorphology, that escarpment shape indicating the flow of ice across that bedrock. And also those eroded boulders themselves, which we've talked about before, the faceted sub-rounded boulders typical of subglacial transport. So that would be an example, I suppose, of the mesoscale outcomes of glacial erosion. And here another example, here at the scale of tens of meters, we're looking at again a moutonnées feature, rock which has clearly experienced glacier overriding, smoothing, polishing, streamlining the rock surface to give this middle scale of glacial geomorphology. And here we can think about the macro or mega scale, the big scale glacial geomorphology. And here you might be thinking, well, hang on, you're talking about landforms, but this looks more like a landscape. There's lots of different things in here. We've got a pyramid peak, we've got our arêtes, we've got a Corrie glacier in there, maybe we've got a valley glacier, we've got a U-shaped valley, we've got mass movement processes on the hillsides. There's lots going on here. Well, indeed there is, and I guess that's a question that you can ask as to whether complex, multi-scale, multi-part landforms, well, is that what a landscape is? Once you start getting together a bunch of connected landforms in an area, well, isn't that really what a landscape is? And here's just some photos from the Canadian Rockies. Actually, the Canadian Rockies in the top, and it's the Rockies further south in the bottom picture there. But you're seeing landscapes that involve lots of different components associated with glacial action, and also if you look hard enough you see lots of other kinds of processes going in there. We have a palimpsest landscape with lots of different things affecting what we see as the final total outcome of that. And that assemblage of landforms associated with a variety of different processes, well, that's when you start thinking about landscape rather than individual landforms. And so, say, in the days when we had an exam with this module, the kind of thing you could be thinking about is as to whether you would define a landscape as essentially a complex regional landform. So here's an area of aerial scouring in West Greenland. There are lots of separate individual landforms in there, down to the micro scale of striations and the meso scale of streamlined hilltops, and at the macro scale, the landscape as a whole is a complex assemblage of landforms. So once you start thinking about a landscape and a region, then inevitably as geographers we start thinking about the geography of landforms. And this is the point that I keep coming back to. So if you remember nothing else from all these geomorphology and glaciology lectures that we've had, I guess for this module the key point really is that there is a geography of landforms. There's a geography of geomorphology. And that's because there's a geography of processes. And that's because there's a geography of glacial and subglacial environments. But the geography of environments leads to this geography or distribution of processes, and that leads to the distribution of landforms and landscapes. And that little diagram there at the bottom kind of ties it all together for me quite nicely. The geography of glaciology gives us a geography of glacial geomorphic processes, and that gives us a geography of glacial landforms. And that geography of glacial landforms, or that idea of glacial landforms distributed with some kind of logical pattern over a region, well, that's what a glacial landscape is. So let's move on and think about landscapes. And we've said before, we can think about landscapes of erosion, landscapes of deposition, composite landscapes that include both erosion and deposition together. Well, in the same way that we separated out the landforms of glacial erosion into different scales, we can do something similar with landscapes of glacial erosion. And the way I'm going to do that is in terms of thinking about the kind of ice mass that created them, the valley glacier or the ice sheet that's creating them. And we talk about unconfined and confined landscapes, or unconfined and confined glacier types. And what we're talking about there is whether the ice mass, the glacier, is confined by its landscape or whether it overwhelms its landscape. So an ice sheet, for example, or an ice cap, those overwhelm their landscape. You can have mountains and valleys and everything else completely buried beneath the dome of an ice cap or an ice sheet. Whereas in an alpine glacier situation, glaciers follow the tracks of valleys, or glaciers form in basins on hillsides to create cirques or Corrie glaciers that then flow. If they extend into an alpine system, those then flow into valleys and follow the valleys, so they're confined by landscape. So ice sheet erosion landscapes are unconfined, and valley glacier or mountain glacier landscapes are confined landscapes. Within each of those there are again different varieties. So we've talked about the landscapes of aerial scouring already. I showed you a picture of that a second ago. Also, for example, under many cold-based glaciers there are landscapes where there really isn't much erosion, erosion-free landscapes. And even in an unconfined glacier setting, there are situations where erosion happens just in one location or one area, but not in an adjacent area. So even though we have an overall unconfined glacier mass, there's still a distribution of locations where erosion is happening and locations where erosion isn't happening. Now, as well as unconfined and confined, as always in geography we can talk about where the two overlap and mix and match, and so we can talk again about composite landscapes. And I'll divide those up into two types for you. Composite in the sense that both unconfined and confined elements are existing at the same time in a region, so contemporaneous, and situations where, not at a single time, but over the course of a long history, the landscape goes from being in an unconfined situation, unconfined glacier, to a confined situation. So for example, if an ice sheet shrinks and it ceases, a single location will stop being in an ice sheet environment and will find itself, as the ice sheet diminishes and reduces to an alpine setting, it will find itself later on perhaps in a confined glacier landscape, simply because of the change in dimensions or geometry of the ice mass itself. So again, as we keep coming back to whenever we're talking about things in glaciers and glacial geomorphology, you can identify a continuum of different types, and there aren't necessarily very sharp, strict boundaries between them. And if you get really hung up on classification, you could get yourself in a bit of a mess. So being too precise on the classifications can just get you a little bit confused. But just be aware of these broad distinctions, but also be aware that there are going to be overlaps and there are going to be overlaps and composite situations between any classification that you dream up. So here's an example of an unconfined glacial geomorphic landscape. This is a landscape of aerial scouring where the whole area has been overridden by an ice sheet, and the whole area has been lowered, it's been scoured, it's been abraded, it's been eroded, and you can see that same pattern of impact across the whole landscape. And here's an example of a confined glacier landscape where you can very clearly see mountains and valleys, and the glaciers are following the valleys in this alpine setting. And when the glaciers disappear, you'll see corries, you'll see U-shaped valleys, and so on and so forth. So that's an alpine, or on a smaller scale, cirque glacier confined landscape. And here, I guess, is an example of a composite landscape. This is a photograph I took of the eastern edge of the Greenland ice sheet we flew over on the plane. And this is an ice sheet environment in that this is the edge of the Greenland ice sheet where it's flowing through the East Greenland mountains towards the sea. But at this point, the ice sheet isn't thick enough to actually cover those mountain tops. And so, if you didn't know you were looking at an ice sheet, you might think you were looking at simply an ice field in the mountains with valley glaciers flowing in between the peaks. And if you look closely at that picture, you can see some mountaintop corrie or cirque glaciation going on in there as well. And certainly over the course of time, as the Greenland ice sheet thickens and then thins again, this landscape will have found itself sometimes under the ice sheet, sometimes with the ice sheet flowing through it to give a more alpine type of setting. Now, as you know, people have done a lot of work on this over the years, and this is one of the classic papers that I keep referring you back to, and I've put a copy of this on the KLE for you to have a look at. Sugden 1978 did some work looking at glacial erosion by the Laurentide ice sheet. So on the basis of air photos, satellite images and glacier modelling, he figured out what we've talked about before, the way of figuring out the thermal regime at the base of the ice sheet. But one of the things he was looking at as part of that were the characteristics of the landscapes across the footprint of the former Laurentide ice sheet. And just very briefly here, you can see he's pulled out an erosional zone, a depositional zone, zones of selective linear erosion, alpine zones, and zones of little or no erosion. So he's doing exactly what we've been talking about, identifying the geography of the geomorphology, and then in that other work of his we were looking at, he was relating that geography of geomorphology to the geography of the basal thermal regime. So look at those two bits of work in combination. And here's another example. This is also Sugden's work. This is from the textbook Sugden and John 76 that I've recommended you to as the old classic textbook that's still worth a look. And again, on this map it's a little bit clearer. This is a map of Greenland with the ice sheet in the middle, and then the ice-free land all around the margins of Greenland. And a similar piece of work here where he's divided up and coded with the shading there. It doesn't really matter at this point. I'm not drawing your attention to where the different landscape types are. I'm really just interested in the figure caption there that I've expanded so you can see it more clearly. The different types of landscape of erosion that he's pulled out there. There are areas where there's little or no sign of glacial erosion, so you might be thinking now on the basis of what we said, perhaps that's cold-based ice and not moving so much, not abrading, not eroding the landscape quite so much. Then the next one down the column is aerial scouring, like that photo I showed you before, where there has been a warm-based glacier, perhaps moving faster, dragging debris across the bed, scouring the whole bed. Selective linear erosion, I'll say more about that in a separate little mini video later on to explain how that works, but selective linear erosion, where there are zones of erosion within an unconfined glacier landscape, but just certain pathways have been eroded where the conditions are just right, and on either side of that no erosion has been happening. It's selective patches of erosion, but not just patches, lines, linear, selective linear erosion. I'll give you a separate little mini video about that following on from this one. And then, as we saw in the previous photos, alpine landscapes, valley glaciers finding their way through the mountains, and cirque landscapes where there are just patches of ice on the mountain tops eroding cirques or corals or combes, as you might have learnt about in your previous work. So that's a nice example of this geography of geomorphology, how different types of erosional landscape, and you could do something similar for depositional landscapes, we'll do that next week, but these different types of erosional landscape are visible in a geographical sense, and they tell us a story, therefore, about the geography of the characteristics of the ice masses that created them. And here's a photograph of selective linear erosion. I think this is from Baffin Island, but don't hold me to that, sorry, I'll come back and talk about that in the follow-up lecture. But you can see what's happening here is that in a zone where broadly there isn't much erosion going on, if you have this kind of planar surface over much of that image, there's this sudden trough cut through that landscape where just along that line the ice sheet was able to be doing more erosion. It's selecting particular locations. Maybe it's to do with something in the rock you're thinking, maybe it's something to do with something in the glacier you're thinking. Well, I'll come back and explain this, and my explanation will be focused on basal thermal regime and variations in ice thickness. And where the conditions are just right, ice starts flowing faster, ice starts eroding. Positive feedback, erosion gives you deeper ice, faster flow gives you warmer ice, and it accelerates and you get this line of erosion through the landscape, even though perhaps there's colder ice on either side, or ice which isn't moving so much on either side. So it's just another example of the types of landscape that are there. And like I said before, the thing to remember is that there's a continuum. It's difficult. I kind of deliberately chose this image earlier to talk about composite and sequential composite landscapes, because it's quite difficult really to work out what you might be looking at there, and it's going to depend also on what's happening over a long time scale. And I talked about the ice sheet being thicker and overriding those mountains, and the smarter ones amongst you might have looked at them and said, well, they look very sharp, they don't look as if they've been overridden by a glacier any time recently, they look as if they've been eroded into by glaciers. That looks like an alpine landscape. The mountains don't look subglacial in a sense, and you're absolutely right. So maybe it's a long time since the ice sheet ever overrode those particular mountains, and since then their morphology has been changed, or maybe they've never been overridden. But you're having that interesting discussion about the glacial history and the glacial characteristics of the glaciers based on looking at the shape of the landform, and that's exactly what you should be doing, and that's where I've been trying to bring you to with these sessions, that you can look at the geomorphology and be trying to figure things out about the glaciers. Or I can say something about the geomorphology and you can say, no, you're being stupid, because look, there's this evidence and there's that evidence. That's what geographers are good at, that's what geomorphologists are good at when they're engaging with glaciology, is kind of ground truthing the outcomes of what the glaciers have been doing. And those glacial landscapes, in the sense of landscapes with glaciers in them, landscapes where glaciers are actually doing work, well, those are left behind afterwards. And this is a photo from the English Lake, this photograph from the English Lake District, present day, where there were, well, up until about 15,000 years ago, 12,000 years ago, there were glaciers here. At some points, this landscape was overwhelmed by an ice cap. And if you compare this image with the previous image where we were saying, oh, that can't have been overwhelmed, look how sharp the mountain tops are, the mountain tops in this image don't actually look that sharp. They kind of look, I mean, that one at the back left, it almost looks smoothed off, as if you can imagine it being almost like a rush moutonne where the ice has overridden it from the left moving towards the right, then there's a steeper slope on the right hand side. I'm not saying that's exactly what happened there, but those mountain tops don't look sharp and jagged. They look smoothed over, and it will be much more believable if I was to say, yeah, well, as I am saying, yep, that landscape was at one point entirely subglacial. But as the glacier shrunk and retreated, the ice cap no longer covered those mountain tops and the ice was confined into the valleys. Then it went away, then colder conditions came back and glaciers grew again, in cirques on the mountainsides, and little valley glaciers started coming back down the valleys and freshening them up and eroding them again, and then they finally disappeared. And the landscape that we're left with today shows us evidence of all those different stages of the long-term evolution of the landscape underneath the ice, or with ice flowing through it through time, or with ice re-establishing itself and advancing, and then eventually the ice disappearing and leaving behind not only the erosional landscape we've talked about today, but also leaving behind deposits where it's entrained sediment, following that erosion, carried that sediment and then deposited that sediment at the end of the glacial period. And so, as well as thinking, as we've done just now, about erosion, we also need to think about deposition, and that's what we'll be doing next week. We'll be coming back with help from colleagues on the module. It won't be just me next week, but we'll be coming back next week and we'll be talking about glacial deposition, so you can tie together these ideas of erosion that we've talked about this time with ideas of deposition next time, to put together a more complete idea of how landscapes emerge. So, by way of conclusion on this session, we can identify processes, landforms and landscapes of glacial erosion. These processes, landforms and landscapes all relate to environmental conditions such as the basal thermal regime. It's complicated because glaciers come and go, they shrink and they retreat and they advance. Everything's changing over time, so it becomes complicated. And so we need to think about not just all the complications of erosion, we also need to think about what else is going on, for example deposition, and for example after that we need to think about, well, what happens right at the very last stages as the glaciers are disappearing, because the last impact that glaciers have on a landscape is at the point of their disappearance. Are there any particular landforms, landscapes or features associated with that? So there's more that we need to talk about yet in the geomorphology, and so we'll come back and we'll do that over the next few sessions.